Hello students, welcome to my class. In this video we are going to be discussing about progressive wave equation, relation between phase difference and path difference, relation between particle velocity and wave velocity. That related questions we are going to be discussing. Let us see the first question. So equation of transverse waves pulse is given as y equal to 9 by 3 plus x minus 10t whole square, where x and y are in the meters is given and time is given in seconds. The speed of the wave pulse they are asking. So here the equation of the wave is given, y equals to 9 by 3 plus it's an x minus 10t whole square. So here it is in the form of, here you can take as ax plus bt whole square you can take. So here if y is the function of ax plus bt, in the sense here you can take as speed formula you will be getting as, this is a coefficient of, it's a coefficient of t by, here you can take as coefficient of x you can write, coefficient of x you can take. So coefficient of t, in the sense here will be getting as b by a you can get. Instead of b here it will be present as 10 will be present. Instead of a here it will be 1 will be present. Velocity of the wave, speed of the wave, which will be equal to 10 by 1, which is nothing but here will be getting as 10 meter per second. So this is the correct answer. Let us see the next question. The equation of the wave pulse is given as y equals to 0.8 by 4x plus 5t plus 4. The amplitude and velocity of the pulse they are asking. So y is in meters and t is in seconds they are asking. So y equals to, here it's given as 0.8 by, this is 4x plus 5t plus 4 it is given. Now here they require the amplitude and velocity. As I said, y equals to, it is in the form of, here you can write as ax plus bt. So y is a function of x and t if you are considering. So velocity of the pulse, which will be equal to, here you can write as coefficient of t by, here you can write as coefficient of x you can write, coefficient of x you can write, which is nothing but coefficient of the t value will be getting as 5 will be getting, coefficient of the x value will be getting as 4. Then here velocity of the pulse, which will be getting as 5 by 4 is nothing but 1.25 meter per second will be getting. And second thing is, here they are asking the amplitude value will be maximum. To get the amplitude is maximum, here we can take, this is 4x plus 5t and plus 4 you can take. So here maximum displacement of the particle, this is the maximum displacement of the particle will be calling as amplitude. If it requires a maximum amplitude, in the sense here you can take, this value will be the minimum value you can take, which is nothing but 0.8 by, here this is some minimum value plus here you can take as 4. Minimum, in the sense you have to consider 0. So here you need to take as, therefore amplitude which will be equal to 0.8 by, this is 4 will be getting, this is nothing but 0.2 meters will be getting. So amplitude will be 0.2 meter and 1.25 meter per second. Direction they are asking, here it is in the form of ax plus bt, right? Here ax plus bt, in the sense here it's going to be traveling along the negative x-axis. So first one is the correct answer. Let us see the next question. A plane progressive wave is shown in the adjoining phase diagram. The wave equation of the wave, if its position shown at t equal to 0, they are asking. Now here you just look at the student from the graph. Here the maximum amplitude, here it is given as, in the graph here this is the maximum displacement, amplitude is given as, this is 0.05 meter, and here it's moving with the velocity is given as this is 300 meter per second it's given. And here distance covered by the wave for one wave, distance covered by the wave for one complete oscillation will be calling as wavelength will be calling, and here to here it will be lambda, and here to here one more wave it's going to be covering as lambda. So total together the distance is given as 2 lambda, which will be given as 0.5 meters is given. So then here lambda value with this here will be getting a 0.5 by 2, which will be equal to 0.25 meters will be getting. Now here velocity here v equals to here the formula will be, so it's a omega by k you are taking. So with this here omega equals to here you can take as v into k you can take. Speed already it's given, speed of the wave is 300 meter per second. K is nothing but here propagation constant will be calling 2 pi by lambda. So instead of lambda you can k value you can take as 2 pi by lambda you can take. Lambda already 0.25 meter, which is nothing but omega equals to 300 into this is 2 pi. This one you can take as 1 by 4. 4 2s are 8 will be getting, so 300 into you can take as 8 pi you can write. And the next thing is here k equals to 2 pi by lambda you are taking, which is nothing but here 2 pi by lambda it's given as 0.25 value, which is nothing but here you can take as 1 by 4. This is 2 pi by here you can take as 1 by 4 you can take, which is nothing but you will be getting as 8 pi you can take. Now you can write the wave equation. Here the wave is propagating along the positive x-axis, so here you can write the equation of the wave will be y equal to a sine it's omega t minus kx you can write. In this equation you have to write the wave equation. So that's nothing but amplitude already we have calculated as it's nothing but 0.05 into sine omega already omega value we have calculated as 300 into 8 pi into t you can take minus here this is k value we calculated as 8 pi into x you can take, which is nothing but y equals to here you can take as 0.05 into sine 8 pi. If you are taking as common in the sense, here we will be writing as 300 t minus here 8 pi already took common, here you can take as minus x you can take. So this is the representation of the wave equation we will be getting. So on the answer will be the third one. Let us see the next question. The next question says a plane progressive wave is represented by y equals to 0.1 sine 200 pi t minus 20 pi x by 17. Y is in displacement in meters, time is given in seconds, and here we require to calculate the frequency, wavelength and as well as the speed of the wave we require. So here the given equation is y equals to 0.1 sine, this is 200 pi t minus it's 20 pi x by 17 you can get. It's in the form of y equals you can take as a into sine omega t minus kx you can take. Now here instead of omega here it will be 2 pi will be present, instead of k here it will be 20 pi by 17 will be present. So here omega you can take as formula will be 2 pi f, which is nothing but here it is given as 200 pi it's given, and this pi gets cancelled, so frequency will be getting as with this 200 times it will get cancelled, so frequency will be getting as 100 Hz will be getting. Now here the next one we need to calculate the velocity of the wave. V equals to here will be getting as omega by k. Omega it's given as 200 pi it's given. K is nothing but here with this you have to calculate here omega value will be 200 pi and the k value you can write it as this is 20 pi by 17. So here you just substitute that value 20 by 17 you just bring into the numerator. So here pi gets cancelled, 20 10 times 17 10 will be getting as 170 will be getting 170 meter per second. Now here we need to calculate the wavelength. To calculate the wavelength here k equals to 2 pi by lambda. With this k value already you know this is 20 pi by 17, which will be equal to you can take as 2 pi by lambda. So pi gets cancelled, 2 10 times it will goes, so lambda which is nothing but here will be getting as 17 by 10, you just cross multiply like this 17 by 10, which is nothing but we'll be getting as 1.7 meters you are getting. So frequency is 100 Hz, wavelength will be 1.7 meter and speed will be 170 meter per second. This is the correct answer. Let us see the next question. A wave is traveling in the positive x direction with the amplitude is given as 0.2 meter, has a velocity of 360 meter per second is given. If lambda equal to 60 meter, then the correct expression for the wave they are asking. Now here you can take this, an amplitude is given as 0.2 meter and its velocity is given as 360 meter per second, and here a wavelength is given as 60 meter. Correct expression represents the wave they are asking. Here the wave is traveling along the positive x direction it's given. Wave is traveling along the positive x direction means here you can write it as y equal to a sin omega t minus kx you can take. First let us calculate the k value and omega value. So k, the value will be getting as 2 pi by lambda, which is nothing but 2 pi by lambda, it's given as 60. So you just keep like this k value, and the second thing is here velocity, just take velocity, you know the formula omega by k. So with this here omega equals to, you can take as v into k you can take, which is nothing but omega equals to, here you can write it as v velocity is given as 360 meter per second and k value will be getting as 2 pi by 60 will be getting. So 66 times here we will be getting as, this is nothing but 6 into 2 pi will be getting. This is the omega value. Now just write the equation of motion. Y equals to, when it is moving along the positive x direction, the progressive wave equation you can write it as a sin omega t minus kx you can write. Then y equals to a value will be getting as 0.2 meter into sin omega, you can write it as, this is 2 pi into 6. So here omega t, this one you can write as 2 pi, I am just taking common, 2 pi into, you can write it as 6t, right? 6 into t you can take, minus here this is 2 pi already I am taking common, here you can write it as some x by 60 you can write. So this is the way you have to write the equation of progressive wave. Y equals 0.2 into sin 2 pi into 60 minus x by 60 will be writing. So third one is the correct answer. Now let us see the next question. A transverse wave pulse of amplitude is given as 0.5 meter and wavelength is given as 1 meter and frequency is given as 2 Hz. Is propagating in a string in the negative x direction. The expression for this wave they are asking. So here the amplitude is given as, here it is 0.5 meter and the wavelength is given as 1 meter and its frequency is given as 2 Hz. It's propagating in a string along the negative x direction. Negative x direction in the sense here you have to take as y equals to a sin omega t plus kx when it is propagating along the negative x direction. Now just write the equation. So omega value here, you know, omega is nothing but, here you can take as 2 pi f you can take. So 2 pi into frequency is given as 2 Hz is given, which is nothing but 4 pi you can take. And here a k value just calculate, k equals to 2 pi by lambda you are getting, which is nothing but 2 pi by lambda, it's given as 1 meter it's given, so that you can take as 2 pi you can write. Then here y equals to, you can write it as a sin omega t. A value is given as 0.5 into sin omega, in the sense here you can write as 4 pi it is given. So here you can write it as 4 pi into t plus, here you can write as this is k value will be getting as 2 pi into x you can write. So the answer will be 2 pi x plus 4 pi t. So second one is the correct answer. Let us see the next question. A wave is traveling along the x-axis is described by the equation y equals to, it's given as 0.05 cos alpha x minus beta t. If the wavelength and the time period of the wave is given as 0.08 meter and 2 seconds is given, then alpha and beta, they are asking appropriate units. Now here the equation of the wave is given as y equals to 0.005 cos, this is alpha x minus beta t is given, where wavelength is given as here lambda is given as 0.08 and time period is given as here 2 seconds it's given. Now here let us calculate the k value. K equals to, here we can write it as 2 pi by lambda, which is nothing but 2 pi by lambda, it's given as this is 0.08. So here 2, here you will be taken 0.04 times, which is nothing but here 0.04 in the sense 4 by 100, it's nothing but 100 by 4 into pi, you can take 425 times, so that you will be getting as 25 pi you will be getting. This is the k value. So k is nothing but here we will be getting as alpha, it's given, instead of here y equals to here this is a cos kx minus omega t, it will be in this form. Instead of k it will be given as alpha is given, so that alpha value will be getting as 25 pi. So instead of beta it's given as omega, you have to take for beta, which will be equal to omega, you can take, which will be equal to, you can write it as 2 pi by t, which is nothing but 2 pi by time period is given as here 2 seconds is given, 2 gets cancelled, so that you can take as pi seconds you can take. Then here beta is nothing but here will be getting as pi you will be getting. So alpha equals to 25 pi and beta equals to pi is the correct answer. Let us see the next question. Equation of progressive wave is given as y equals to a sin pi into t by 2 minus x by 4, where t is in seconds and x is in meters. The distance through which the wave moves in 8 seconds is they are asking. So y equals to, here you will be getting as a sin pi into here this is t by 2 minus x by 4. Now here they are asking distance value, they are asking. First let us calculate y equals to, here it is in the form of a sin pi, when you are taking inside this is pi t by 2 minus pi x by 4 you can take. It's in the form of y equals to a sin omega t minus kx. First let us calculate, instead of omega here it is given as pi by 2, instead of k here it will be pi by 4. Velocity of the wave formula will be ratio of the omega by k, you can get. Omega value will be getting as pi by 2 and k value will be getting as pi by 4. You just reverse this one, 4 by pi will be getting. So pi gets cancelled 2 times. So here the velocity of the wave will be getting as 2 will be getting. Distance through which the wave moves 8 seconds they are asking. Distance which will be equal to, you can take the speed into time you can take. So speed already we calculated as 2 into 8 seconds they are asking. 2 8 0 will be getting as 16 meters will be getting. This is 16 meters. So 16 meters is the correct answer. Let us see the next question. The displacement is given in centimeters produced by the simple harmonic wave is y equals, it's given as 10 by pi sine 2000 pi t minus pi x by 17 it's given. Now here the periodic time and maximum velocity of the particles in the medium will be respective they are asking. Here there is a correction, students. Here don't take as here 2000, here you just take as 200 only. So y equals to, here you can take as 10 by pi sine, this is the value will be getting as 200 pi into t minus this is pi x by 17. Now it is in the form of y equals to a sine omega t minus kx. So instead of omega here it will be 200 pi, instead of k you can take this is pi by 17 will be getting. So a amplitude here will be getting as 10 by pi and omega value will be getting as 200 pi, and here k value you are getting as pi by 17 it is given. Now here the periodic time and maximum velocity of the particles they are asking. So here maximum velocity of the particle, the formula will be getting as, for particle maximum velocity will be getting as A into omega. A value will be getting as 10 by pi it's given, omega value will be getting as 200 pi, so 1 pi gets cancelled, you will be getting as, so V maximum value will be getting as 200 into 10, you will be getting as 2000 meter per second will be getting. And here with this time period we need to calculate omega equals to 2 pi by t, with this time period which will be equal to 2 pi by omega. So here omega value, it's nothing but here it's given as 2 pi by omega, it's nothing but 200 pi you can get, so pi gets cancelled 200 times. So time period will be getting as, this is 1 by 100 will be getting, it's nothing but 10 power minus 2 seconds will be getting. So answer will be 10 power minus 2 seconds and 2000 meter per second is the correct answer. Let us see the next question. The next question says, a transfer wave is described by the equation y equals to y naught into sine 2 pi into ft minus x by lambda. The maximum particle velocity is 4 times the wave velocity is given. At which wavelength they are asking? The maximum velocity here they are asking for a given wavelength they are asking. So here the equation you can write y equals to here y naught into sine. This is here you can write as 2 pi ft minus 2 pi into x by lambda you can take. I am just taking inside. Instead of amplitude here it's in the form of, here you can take it as y equals to, here you can write it as a sine omega t minus kx you can take. Instead of omega here it will be 2 pi ft there, instead of k here you have to take. So amplitude here it is given as y naught, its omega value here it will be 2 pi f is given already. So V maximum for a particle which will be equal to a omega will be getting. A is nothing but here y naught you can take, here omega you know already, here it's given as 2 pi f. And here velocity of the wave will be, wave velocity the formula will be omega by k will be getting. Omega you know already 2 pi f, k value will be getting as 2 pi by lambda you can take. So 2 pi gets cancelled, so here velocity of the wave will be getting as f into lambda. Here the condition is given as the maximum particle velocity is 4 times that of the wave velocity is given. Velocity of the maximum particle which will be equal to 4 times of the velocity of the wave it's given. So you just substitute these values. Here V maximum value will be getting as, this is 1 and this is 2 you can take. It's a y naught into, here will be getting as 2 pi f which will be equal to 4 times of wave velocity. Wave velocity will be getting as f into lambda will be getting. Here just cancel f and f you have to cancel. So with this wavelength the value will be getting as lambda equals to pi into y naught by, this is 2 times it has to cancel, pi into y naught by 2 will be getting. So lambda equals to will be getting as pi into y naught by 2 is the correct answer. Let us see the next question. A wave is given by y equals to 3 sin 2 pi into t by 0.04 minus x by 0.04, where y is in centimeter, frequency of the wave and the maximum acceleration of the particle they are asking. So here the equation is given as y equals to, here you can take as, this is 3 into sine, here you can take inside, this is 2 pi into t by 0.04 minus 2 pi into x by 0.01. So it's in the form of y equals, you can take as a sine omega t minus kx you can write. So here instead of omega, here it's given as 2 pi by 0.04 instead of k, here you can take as 2 pi by 0.01 you can take. They're asking the frequency value omega equals to, you know, the formula 2 pi f, but instead of omega here, you know already 2 pi by 0.04 you can take, and here this 2 gets cancelled, and this pi gets cancelled. Then f, which will be equal to, you'll be getting as with this 1 by 0.04 you can take, which you can write it as 4 by 100. It's nothing but 100 by 4 you can take. So the frequency value here 25 times, here the frequency will be getting as 25 Hz you will be getting. So this is the frequency you are getting. Now let us calculate the maximum acceleration of the particle. So maximum acceleration of the particle doesn't mean a maximum for a particle you will be getting as omega square into a you can take. This is a formula for maximum acceleration, which is nothing but here you can take as 2 pi by t. So it's a 2 pi by t whole square you can take. 2 pi by t whole square into amplitude, already you know here that value is given as 3 is given in the question. So just substitute this value. 2 pi 1 by t is nothing but so frequency you just substitute. So here are 2 this is 2 pi by here time period you know we don't know, but frequency instead of that one you just substitute the frequency value. So you will be getting as nearly some 0.04 will be getting. This is whole square you can take into 3 you can take. Then here when you are simplifying this equation, and right this equation will be getting as nearly 7.394 will be getting, which is nothing but 7.4 you can take. 7.4 into 10 power 4 centimeter per second square will be getting. It's approximately 7.4 into 10 power 4 centimeter per second square you are getting. So frequency will be, this is 25 Hz will be getting, and a maximum value 7.4 into 10 power 4 centimeter square will be getting. Let us see the next question. The next question says a transverse wave along the string is given by y equals to 2 sine 2 pi 3t minus x plus pi by 4 it's given, where x and y are in centimeters and t is given in seconds. The acceleration of the particle located at x equal to 4 at t equal to 1 seconds they are asking. So here the equation is given as y equals to, here you can write as 2 into sine. You just take inside the 2 pi into here 3t, which is nothing but 6 pi t you can take, minus 2 pi into x. So this is 2 pi x you can take, plus here you can take as pi by 4 you can take. This is a displacement. And here you can take acceleration is nothing but here the acceleration of the particle they are asking. Acceleration and simple harmonic motion you learnt already, which is nothing but minus omega square into y you are taking. Minus omega square into y, but time x value here you need to substitute as 4 centimeter, and here at time t equals to 1 second we need to substitute. So then you have to substitute a equal to omega square. Instead of omega here it will be 6 pi will be there. So here you can write as minus omega, here you can write as 6 pi it's given. So 6 pi whole square is nothing but here you can write as 36 pi square you can take, into y you can write it as, this is 2 into sine 6 pi t minus 2 pi x, plus here you can write as pi by 4 you can write. So which is nothing but minus 36 pi square into 2 into sine 6 pi into t value will be getting as 1 second into 1 minus 2 pi into x value will be getting as 4, plus here you can write as pi by 4 you can take, which is nothing but minus 36 pi square into 2 into sine. This is here you can write as 6 pi minus 8 pi plus pi by 4 will be writing. So here you can write it as minus 36 pi square into 2 into sine. This is 6 pi minus 8 pi will be minus 2 pi. So here we'll be writing as minus 2 pi plus pi by 4 you can take. Minus, if I am taking common, a value will be writing as, so here minus, if I am taking common outside, here this is minus 36 pi square into, so here minus 2 sine, here you can write it as, this is 2 pi minus pi by 4 you can take. So minus into minus plus will be getting 36 2 0 will be getting as 72 pi square into, this is sine 360, 36 into 2 will be 72 pi square into sine, here will be writing as, this is 360 minus theta, it will be in the form of sine 360 minus theta, you can write it as sine theta. So sine theta is nothing but, here you can write it as sine 45 degrees will be writing, sine 45 value you can write as 72 into pi square into, here you can take as sine 45 will be 1 by root 2 you can take, and again here you just substitute this value as 36 into, here into 2 you can take, this 2 you can write it as root 2 into pi square into 1 by root 2 you can take. So root 2 gets cancelled, here the answer will be getting as 36 root 2 pi square centimeter per second square will be getting. So first one is the correct answer. Let us see the next question. The next question says a transverse sinusoidal wave of amplitude is given as A and wavelength is given as lambda and frequency is given as n, is traveling on a stretched string. The maximum speed at any point is given. Maximum speed at any point is given as v by 10, where v is the speed of the propagation of the wave, and amplitude is given as 10 power minus 3 meter, and v is given as 10 meter per second, and lambda is given, and then lambda and frequency value they are asking. Here you know the formula v maximum, the formula will be getting as a omega will be getting, that's nothing but here it is given as v by 10 is given, but already v value is given as 10 meter per second is given, that you need to take. So when you are substituting here, this is a omega, a value you can take as this is okay, which is nothing but here you can take, this is a omega equals to v by 10 you can take, amplitude is given as 10 power minus 3 into, here you can take as omega. So this is, here you can take as velocity, already it's given as 10 meter per second it's given, that you have to take 10 by 10, here will be getting as 1 will be getting. So omega value here you can take as 1 by 10 power minus 3, which will be equivalent to, here you can take as 10 power 3 you can take. Omega is nothing but you can take as 2 pi f, which is nothing but here you can take as 10 cube. So then frequency with this here will be writing as 10 power 3 by 2 pi you can take. So the frequency value will be getting as here 10 power 3 by 2 pi h. This is the frequency value. Now just calculate the wavelength, we just calculate. You know the formula, velocity of the wave will be v equal to f lambda you can take, velocity already it's given as 10, and this is nothing but frequency calculated as 10 power 3 by 2 pi into you can take as lambda. With this 10 gets cancelled, here it becomes square, so lambda which will be equal to, you can write it as 2 pi by 10 square you can take, which is nothing but here you can take as 2 pi into 10 power minus 2 meter you can take. So the wavelength will be 2 pi into 10 power minus 2 meter, frequency will be 10 power 3 by 2 pi hertz will be getting. So third one is the correct answer. Let us see the next question. A transverse mechanical harmonic wave is traveling in a string. Maximum velocity and maximum acceleration of the particle on a string is given as 3 meter per second and 90 meter per second square it's given. And if the wave is traveling with a speed of 20 meter per second on the string, so write the wave function describing the wave. So just look at students here, V maximum here it is given as, V maximum formula will be beginning as A omega, which is nothing but here it is given as 3 meter per second, And also here A maximum is given. A maximum formula will be omega square A. That value is given as 90 meter per second square. It's given. This is meter per second. Now here when you are dividing these two values, here A maxima by here V maxima, when you are talking, A maxima is nothing but here omega square A by here V maxima will be getting as A omega. Here when A gets cancelled, omega gets cancelled, which is nothing but here will be getting as omega square A value is 90 by 3 you can take. So then omega will be left over here 390 30 times. So here we will be getting as omega value will be getting as 30 radian per second will be getting. Now here I just take here V maxima equals, the formula, it's a omega. V maxima is given as 3 meter per second. Amplitude we need to calculate. Omega value already 30, 10 times. So here the amplitude will be getting as, you just take this side, 3 1 times 3. So here 1 by 10. 1 by 10 is nothing but will be getting a 0.1 meter will be getting. So here you can write the wave function describing the wave. Here you can take, it's a plus or minus, they have not mentioned anything. So you just take the y equals to a sin omega t plus or minus kx you can write. So this is the equation of the wave. Then y equals to amplitude already 0.1 into sine. Omega already calculated as 30 into t plus or minus k value. K you will be getting as, we just calculate k value. V equals to omega by k will be getting, then k equals to, you can take as omega by v. Omega value 30 and speed is given as, v value will be getting as 20 you can get. Already here it's given as, so traveling with the speed of 20 meter per second is given. That value you have to take 3 by 2. 3 by 2 is nothing but here will be getting as 1.5 will be getting. So here propagation constant will be getting as 1.5. Then you have to take here, this is 1.5 into x you have to take. This is the equation of the wave. 0.1 sine 30t plus or minus 1.5 into x. Second one is the correct answer. Let us see the next question. The next question says here, a particle on a stretched string supporting a traveling wave takes 5 milliseconds to move from its mean position to the extreme position. So mean position to the extreme position, it's going to be moving in 5 milliseconds. The distance between the two consecutive particles which are at their mean positions is given as 2 centimeters. And here find the frequency and wavelength of the wavelength and the wave speed they are asking. Let us take here one wave is traveling in the medium in the sense. This is a wave which is going to be traveling in the medium you can take, and here I am just taking the 2 points I am just taking. Let us take this the A point and this is the B point you can take. So it takes 5 milliseconds to move from the mean position to the extreme position. This is the mean position at the point A, and here this is an extreme position you can take. And how much time it will take in this sense, here to here it will be taken as t by 4 seconds it will take. That means t equals will be getting as t by 4. T already it's given as 5 milliseconds, 10 power minus 3, which will be equal to t by 4 you can take. With this we can calculate the time period. Time period 4 into 5 will be getting as 20 into 10 power minus 3 seconds will be getting. With this frequency, which is nothing but reciprocal of the time period, 1 by 20 into 10 power minus 3. 10 power minus 3 when you are bringing into the numerator, 1000 by 20 you can take. Here this is 50 times it goes. So the frequency value will be getting as 50 Hz you will be getting. This is the frequency of the wave. Now here the next condition it is given as the distance between the two consecutive particles which are at their mean position. Here A particle and as well as B particle, they are at the mean position. So the distance between these two will be calling as wavelength, will be calling, it's nothing but here we can write as lambda by 2. So that value is given as lambda by 2, value is given as 2 centimeter, it's given. Then lambda value will be getting as 4 centimeter. So just convert into meters, so 4 into 10 power minus 2 meter will be getting. This is the wavelength value. Now let us calculate the V value. V is nothing but velocity of the wave is nothing but ratio of the omega by k you can take, or else you can take as already f into lambda, you just multiply these two values. So 50 into 4 into 10 power minus 2 you can take. 54 that will be getting as 200 into 10 power minus 2, this so plus 2, and here minus 2 gets cancelled, here will be getting as 2 meter per second will be getting. So here the velocity will be getting as 2 meter per second. Velocity is 2 meter per second, and lambda value 4 into 10 power minus 2, and here frequency value will be 50 Hz. So this is the correct answer. Now let us see the next question. The equation for a wave traveling in x direction, here it is given as y equal to 3 centimeter sine 3.14 centimeter power minus 1 into x, 314 second inverse into t is given. So find the acceleration of the particle at x equal to 60 centimeter and at a time t equal to 0.11 second they are asking. So we need to differentiate this function, students. Here let us first see how to calculate the velocity and acceleration. So here it's y is given as, this is 3 centimeter into, here you can take as sine, this is 3.14 per centimeter into x, minus this is 314 per second into t is given. Now here velocity first you just calculate, students. Velocity is nothing but here you can write as dy by dt. When you are doing differentiation this function, here you can write it as 3 into here sine theta, you can write it as d by dx of sine x will be getting as cos x you can take. So here you can write as cos of, here you can write as this is 3.14. This is right, the units I am not going to be taking, students. Here 3.14 into x minus here you can take as 314 into t you can take. This is a cos x into here you can take as 314 you can take. X is a constant value when you are doing differentiation with respect to the t. So here you can take as this one alone, again you have to do the differentiation. So here 314 into t you can write it as 314. So this is the velocity value will be getting. So here you can take as this is velocity which will be equal to 3 centimeter is given. So you just convert 3 into here 10 power minus 2 into 314 into you can take as 314 into this is into cos, here you can take as 3.14x minus here you can write as 314 t you can substitute. Now you just calculate acceleration, you just calculate a equals to here you can write as dv by dt. Again you just do the differentiation, students. So 3 into 10 power minus 2 into 314 is a constant value, and again when you are doing differentiation, d by dx of cos x value will be getting as minus sin x, d by dx of sin x is cos x, and d by dx of cos x here you can write as minus sin x you can take, students. So here when you are doing here you will be getting as minus sin, here again you can write as 3.14 into x minus 314 into t into, again you are doing differentiation with respect to the t, so x you can make it as constant, so here you can write as 314 alone. Now here you just take here acceleration when you are taking, this is minus this is minus value will be getting minus into plus minus, you can take 3 into 10 power minus 2 into 314 whole square, you can take into sine. Here you can take as 3.14x minus, here you can take as 314 into t, you can take. Now just rewrite this equation as here acceleration, here they are asking at x equal to 60 centimeter. At x equal to 60 centimeter, and here on the time t equal to 0.11 second, you can get. So this is minus 3 into, just substitute that values, 314 whole square into sine. This value here you can take as pi, you can take. So here 3.14 I am just taking as pi, I am just taking here 6 centimeters. I think it's not 60, and here it will be, I think so it is 6 alone. This is a student, there is a correction will be there, it is not 60, and here you have to keep it as 6 alone. So here you just take it as, this is x value you can take it as 6, you can take. So here instead of 3.14 you can take it as 6 pi, you can take, instead of 3.14 you can take minus 314 into t when you are taking. So here you just multiply 314 into t into 0.11. Again you can write it as, here you can write it as this one as 11x, 11 pi you will be writing, 11 pi you can take. So 6 pi minus pi you will be getting as, this is almost you will be getting as minus 5 pi you will be getting, this is sine minus 5 pi. So here sine 5 pi value almost will be getting as 0 will be getting. So here this value sine 5 pi value will be 0, then acceleration value will be getting as 0 meter per second square will be getting. So 0 is the correct answer. Let us see the next question. The next question says here the phase difference between the waves is given as, here y1 is given as 10 power minus 6 into sine 100t plus x by 50 plus 0.5 meter, and y2 is given as 10 power minus 6 cos 100t plus x by 50, you can take, where x is expressed in meters and time is given in seconds is given is approximately. So let us take, students, here y1 equals to 10 power minus 6 into sine, this is 100t plus x by 50 plus, here we will be getting a 0.5. This whole thing you will be calling as phase, will be calling. Let us take, this is the initial phase, I am taking as pi 1, and y2 it's given as 10 power minus 6. Here sine cos function is given, that cos function you just rewrite as sine function. It's nothing but sine 90 plus theta will be getting as cos theta. So here it is 100t, I am just rewriting this equation will be like this, 100t plus, this is x by 50 plus, here you can take as pi by 2 you can take. So whenever you are going to be calculating the phase difference, both the functions should be either you can take in sine function or cosine function you can take, then only you have to talk about the phase difference. Let us take this is as pi 2 you can take. So delta phi, which is nothing but here you can take as pi 2 minus pi 1 you can take. So pi 2 value is given as here 100t plus, this is x by 50 plus pi by 2 minus 100t minus x by 50 minus 0.5 you can take. So plus 100t minus 100t plus x by 50 minus x by 50 gets cancelled. So pi by 4 in the sense 3.14 by 2 you can take minus 0.5. This is nothing but here we will be getting as 1.5 second we will be getting minus 0.5. So then delta phi value, phase difference value will be getting as 1.57 minus 0.5. So nearly will be getting as 1.07 will be getting. This is in radian per radians. So it's a 1.07 radian is the correct answer. Let us take the next question. The phase difference between the 2 points separated by distance. The phase difference between the 2 points separated by distance 0.8 meter in a wave of frequency is given as 120 Hz is given as pi by 2. phase difference is given as pi by 2, the velocity of the wave they are asking. So phase difference between the 2 points are separated by distance 0.8 is given, means here it's given as path difference is given. Here we just take as path difference value between the 2 points is given as 0.8 meters is given. And here phase difference and path difference relation is phase difference, which will be equal to 2 pi by lambda into, you can take as path difference, you can take path difference. So phase difference already it's given as pi by 2, which will be equal to, here you can take as 2 pi by lambda into path difference is given as 0.8. Here this pi gets cancelled, so with this lambda equals to, here you can take as, just cross multiply like this, 2 2s are 4, 4 into 0.8, nearly will be getting as 3.2 meters will be getting. This is the lambda value. Velocity they are asking. Velocity of the wave, the formula will be getting as v equal to f lambda. F is given as 120 and here lambda value you can get as 3.2. This 10 into 3.2 will be getting as 32. 32 into 12 you can take, which is nothing but nearly will be getting as 384 meter per second will be getting. This is the velocity of the wave. Let us see the next question. The path difference between the two waves they are asking, right? Here y1 is given and as well as y2 is given. y1, which is given as here a1 sine omega t minus, this is 2 pi x by lambda it's given, and here y2, which is given as a2 into cos function is given. This cos function I am going to be changing as sine function. Sine 90 plus theta you can write as cos theta. So here I am just rewriting this equation as y2 equal to a2 into sine, this is omega t minus 2 pi x by lambda plus pi it's given, sine 90 plus theta. Sine 90 you can write as pi by 2. So this is 90 plus theta will be getting as cos theta. Now just calculate the path difference they are asking. To calculate the path difference, first you need to calculate the phase difference value. So this is the initial phase pi 1 you can take, and this will be the second phase you can take as pi 2. So when you are simplifying this one, delta pi equals you can take as pi 2 minus pi 1. The difference between these two directly you can take without substituting. Omega t get common, 2 pi x by lambda is common, and here we will be getting as, so delta pi value here will be getting as pi plus, here will be getting as pi by 2 will be getting. Delta phi is nothing but pi plus pi by 2. Delta pi in terms of the path difference means phase difference, which will be equal to 2 pi by lambda into, you can take as path difference, you can take path difference, which will be equal to pi plus pi by 2 will be getting. Then here it's nothing but path difference, which will be equal to, just cross multiply this one, lambda by 2 pi into here this is pi plus pi by 2 will be getting. This is a path difference, lambda by 2 pi into pi plus pi by 2. Let us see the next question. Equation of the progressive wave is given as, so here y equal to, it's given as 0.2 cos, pi value you just take inside, this is nothing but 0.04 pi, here this is a pi value you just take inside, 0.04 pi into t plus, here you can get as 0.02 into pi x minus, here pi into pi will be given as pi square by 6. This is the equation is given. The distance is expressed in centimeter and time is given in seconds. What will be the minimum distance between the two particles having the phase difference will be pi by 2. So phase difference they are asking, here you just calculate the minimum distance. Minimum distance is nothing but path difference they are asking. So here instead of here it's, you can take as, this is omega t plus or kx, this is y equal to a cos, here you can take as omega t plus kx plus pi. It is in this form. Instead of k value here you can take as, here will be getting as 0.02 pi will be getting. K k is nothing but here you can take as 2 pi by lambda, which is nothing but 0.02 pi you can take, and here this pi gets cancelled. Then here lambda value will be getting as 2 by 0.02 you can take, 0.01 times, it's nothing but 1 by 100, it's nothing but here will be getting as 100. It is in centimeters. Lambda you are getting as 100 centimeter. Then there is a relation between phase difference and path difference. Delta pi equals to 2 pi by lambda into you can take as path difference you can take. Then path difference delta x, it's nothing but delta x you can take. Delta x is nothing but lambda by 2 pi into you can take as delta pi you can take. So lambda value already 100 by, this is 2 pi into phase difference already it's given as pi by 2. Pi gets cancelled, 2 2s are 4, 4 or 25 times it is going. So here the path difference value will be getting as 25 centimeters will be getting. So this is the correct answer. Let us see the next question. At a moment in a progressive wave, the phase of the particle executing SHM is given as pi by 3. Then the phase of the particle 15 centimeter ahead and at a time t by 2 will be there asking. Now let us see this question, students. At a moment in a progressive wave, the phase of the particle executing SHM is given as pi by 3 is given. Phase of the particle 15 centimeter ahead and at a time t by 2 will be if the wavelength is given as 60 centimeter. So first you have to talk about wavelength is given as 60 centimeter and there is a the phase of the particle 15 centimeter ahead is given. That means here path difference value is given as 15 centimeter. Let us here delta phi, which will be equal to here the relation between phase difference and path difference will be 2 pi by lambda into path difference you can take. So here which is nothing but this is 2 pi by lambda into path difference will be getting as 15 will be getting, and the lambda also you have to substitute, this is 60 and 15 2's 4's will be getting 2 times here the phase difference will be getting as pi by 2 will be getting. So here at a moment in a progressive wave, the phase of a particle executing SHM is pi by 3. So one particle phase is given already, it is pi by 3 with another particle. Then right, both they are going to be undergoing executing SHM. Then delta phi, which will be equal to pi by 2 will be getting. Delta phi in the sense here you can take as pi final minus pi initial you can take, which will be equal to pi by 2. So here or else you can take as pi 2 minus pi 1 you can take. So pi 2 we don't know final value, but here it's given as initial value is given, initial particle executing with a phase of pi by 3 it's given. So pi 2 minus pi by 3 which will be equal to pi by 2 you can take. Then here pi 2 which will be equal to, this is pi by 3 plus here you can take as pi by 2 you can take. So when you are doing LCM here will be getting as 5 pi by 6 will be getting. So then the phase of the particle 15 centimeter ahead and at a time t by 2 they are asking, right? So this is the second phase value they are asking, that is at a 5 pi by 6 will be getting. So this is the correct answer. Let us see the next question. The phase difference between the particles A and B for a wave located as shown in figure they are asking. And here first you just calculate the phase difference, students. So here this is the here distance traveled by the wave for one complete oscillation will be calling as for one complete time period will be calling as wavelength will be calling. Then here to here you will be getting as a wavelength will be lambda by 2. Here to here it will be wavelength will be lambda by 2. So 0 to 8 is given as here lambda by 8 is given, and here A and B we need to calculate the path difference value. So here you can take, so this distance first let us calculate here. So if you want to calculate this distance, in the sense here what you can get here, this is nothing but lambda by 2 minus here lambda by 8 you can take, which is nothing but here will be getting as this LCM you can take as 8 you can take, it's a 4 lambda minus lambda you can get it as 3 lambda by 8 will be getting. So here from A to this point here will be getting as 3 lambda by 8, and here to here it will be lambda by 2, then here to here it will be lambda by 4 you can take. That means here total path difference between the A and B, right? Total path difference between A and B, this A point and B point will be, then here to here will be getting as 3 lambda by 8 plus, then again here this is a point, some C point you can take, right? So here AC path difference you can take it as lambda by 2 minus lambda by 8, which is nothing but 3 lambda by 8. Then here delta x between A and B. Path difference, when you are calculating path difference between A and B will be AB, which is nothing but here you can take as path difference between distance between AC plus here you can take as CB you can take. So here delta x AC value will be getting as 3 lambda by 8 will be getting, plus here CB value will be getting as lambda by 4 you can take. Again you just take LCM, then delta x path difference between A and B will be getting as, so 8 you can take LCM, this is 3 lambda plus 4 2 0 will be getting 2 lambda, it's nothing but 5 lambda by 8 will be getting. Now the path difference will be getting as 5 lambda by 8 will be getting. Now they are asking the phase difference value, therefore phase difference between those two particles will be 2 pi by lambda into you can take as path difference. So it's a 2 pi by lambda into here you can take as path difference will be getting as 5 lambda by 8 you can take. Here lambda gets cancelled, here this are 2 4 times here, which is nothing but will be getting as pi by 4 will be getting. It's nothing but 5 pi by 4. So 5 pi by 4 is the correct answer we will be getting. Let us see the next question. A sine wave is traveling in a medium. The minimum distance between the two particles always having the same speed they are asking. Let us take, students, here the wave I am just going to be taking here. This is a wave we can take. Here I am just considering as here two particles I am going to be taking. This is A particle, B particle, and this is, let us take the C particle you can take. Here this is the slope value will be getting, means here all the particles here above these points they are going to be trying to come like this. Here at this point here slope value will be 0 will be getting, whereas at this point here again here the particles trying to move upwards like this, and here also will be getting like this. So these two particles here they are at the mean position. A particle is at the mean position and B particle also will be at the mean position. So here A particle and B particle means here you just look at, students, here they are trying to move A particles right above the A point. Here all the particles they are trying to move down, and here this B points here they are trying to move up the particles. So here velocity magnitude will be same only, velocity of the magnitude here it will be same only, but they are in different in directions, right? So means here but they are asking the minimum distance, they are asking minimum distance. Here A, B, C, like when you are continuing the minimum distance in the sense here between this one will be getting as lambda by 2, and A and C you will be getting as between these will be getting as lambda will be getting. And suppose one more wave if I am talking in the sense here again 3 lambda by 2 like that will be getting. So lambda by 2 lambda, so 3 lambda by 2, which are the particles lying at these distances, they will be having the same speed, but they are asking the minimum value. So here the minimum distance doesn't mean, so minimum distance alone we need to consider between the A and as well as B alone, that is nothing but here will be getting as lambda by 2 will be getting. Let us see the next question. The next question says a sine wave is traveling in a medium. a particular particle has zero displacement at a certain instant, the particle closest to it having zero displacement is at a distance. So here when the sine wave is traveling in the medium, this is a sine wave is going to be traveling in the medium, you can take. This is a sine wave you are taking. Here a particle will be having the zero displacement, like you can take this is a particle, this is a B particle, C particle, and this is a D particle you can take. At time t equal to 0, here a particle will be at the mean position and even B particle also at the mean position. The particle which is closest to it having the zero displacement, a particle will be at zero displacement. Why? Because it is starting from the mean position and here it's going to be moving down like this, and here at B particle, here at the B particle, here all the particles they are trying to move like this, and here the minimum distance, here B particle also will be at the zero displacement will be getting initially, and A particle also will be at the minimum displacement 0 will be getting. So here the particle which is closest to the this A particle in the sense B alone, not the C particle or D particle. So the minimum distance between A and B will be getting as wavelength, half of the wavelength will be getting as lambda by 2 you are taking. So lambda by 2 is the correct answer. Let us take the next question. Two simple harmonic motions A and B is given, and here y1 is given as a sin omega t plus pi by 6 is given, y2 is given as a sin omega t plus 3 pi by 6 is given. The maximum displacement of the A will be there asking, right? The maximum displacement doesn't mean here you can take. First let us calculate the phase difference value. Here it's given as y1 which will be equal to, it's an a sin omega t plus pi by 6 it is given, and here y2 value is given as a sin omega t plus, this is 3 pi by 6 secant. The phase difference means here between these, this is the initial phase you can take pi 1 and this will be the final phase you can take as pi 2 you can take. So phase difference which is nothing but will be getting as 2 pi by lambda into you can take as path difference you can take as delta x. So as phase difference which will be equal to time difference concept you have to take students. Here they are asking the time period they are asking here. So phase difference which is nothing but phase difference which is nothing but here you can take as 2 pi by t into you can take as time difference you can take as delta t you can. Phase difference between these two particles, here it will be omega t plus omega t gets cancelled. Here we will be getting as this is 3 pi by 6 minus pi by 6 which will be equal to 2 pi by t into, here we will be getting as delta t will be getting. So 3 pi minus pi will be getting as 2 pi by 6 will be getting, it's 2 pi by 6 which will be equal to 2 pi by t into delta t will be getting. So 2 pi gets cancelled, delta t time difference value will be getting as t by 6 will be getting. Means initially the particle at time t equal to 0, where is its location in the sense? Here let us take here. Let us take two particles you can take while it's moving here. At a time t equal to 0 when you are taking y1 value. So here I am just talking about this y1 value. y1 equal to here what you can take. This is a sin. This is t when you are putting 0. Here a sin pi by 6 will be getting. This is a sin 30. It's nothing but a by 2 will be getting. Right. This is the first particle. And at time t equal to 0, here second particle where it will be located. Its displacement is nothing but here you can put the value as 0, t value, that's nothing but a sin into, this is 3 pi by 6 will be getting. So here we'll be getting as sin 90 Sine 90 is 1. Here will be getting as will be A will be getting. That doesn't mean here one particle will be here. This is an A particle you can take. A particle is at a distance of A by 2 will be getting, and a B particle you can take as at a displacement here will be getting as this is a B particle you can take. So this is a B particle you can take. Here it is at an amplitude. Here A will be getting. So here between these two, here we calculated the time gap value. We have calculated as delta equal to T by 6 you can take. Means maximum displacement is nothing but here they are asking the maximum displacement of A they are asking. Maximum displacement is nothing but amplitude will be calling amplitude. That means this amplitude of A will be later than B will be getting with by T by 6 seconds will be getting. That means here amplitude of maximum displacement A, this A will be here, later T by 6 seconds will be getting, right? Maximum amplitude will be getting later for A particle, later T by 6 will be getting, right? This is the T by 6 seconds later will be getting, that's the meaning. So later than that for B by T by 6 seconds is the correct answer. Let us see the next question. The next question says the equation is given as y equal to a cos square 2 pi nt minus 2 pi x by lambda. It's given. It represents a wave is given, and here then they are asking the amplitude, frequency, and with the wavelength they are asking. I just rewrite this equation as y equals to a into cos square. This is 2 pi nt minus 2 pi x by lambda you can take. You know the formula for cos square theta. Cos square theta you can write it as 1 plus cos 2 theta by 2 you can take. So this is a formula for cos square theta. I am just rewriting this equation as y equal to a into cos square theta you can write as a into here 1 plus cos 2 theta, 2 into here you can write it as this is 2 pi nt minus 2 pi x by lambda by 2 you can write. This is, I am just rewriting this formula. So then here when you are simplifying this one, y equals here will be getting as a by 2 plus this is here you just multiply with the a value, a by 2 into cos 2 pi into 2 will be getting us 4 pi n into t minus it's 2 into 2 pi x will be getting us 4 pi x by here will be getting us lambda will be getting. So this is the equation will be getting. Now here we just calculate the amplitude and everything here. So here amplitude you are getting as a by 2 will be getting. Here the amplitude value will be getting as a by 2. This is an amplitude of the wave will be getting, and this is from the mean position. Initial displacement will be getting as a by 2 distance. Now here we need to calculate the frequency. So here omega equals will be getting as 2 pi f, which is nothing but f equals to here you can take as omega by 2 pi you can take. So here f which will be equal to omega value here you can get it as cos omega t. So here instead of omega here will be getting as 4 pi n will be getting 4 pi n by here you can as 2 pi you can take 2 pi 2 times, so here you can as 2n will be getting. So frequency will be 2n will be getting. Next they are asking wavelength value. K equals will be getting as 2 pi by lambda. With this lambda equals here you can as 2 pi by k you can take. So 2 pi by k value here instead of k here will be getting as 4 pi by lambda will be getting. Here omega equals to 4 pi n, and here a k value you can take as 4 pi by lambda. it's 4 pi by lambda. I just bring into the numerator 2 pi 2 times, so here we'll be getting as lambda by 2 will be getting. This is the k value. So k is lambda by 2, amplitude will be a by 2 and frequency will be 2n, and right, lambda by 2 is the correct answer. Let us see the next question. The next question says the equation of the sine wave. The equation of the wave is given by y equals to 10 sine 50t plus 5x. So y is given as 10 into sine. This is 50t plus 5x. It's given. It is in the form of y equal to a sine omega t plus kx. X, y are in meters and t is in given as seconds. The ratio of the maximum particle velocity with the wave velocity they are asking. So here a maximum particle velocity, the formula will be getting as a omega will be getting a omega, and wave velocity of the wave will be getting as here omega by k. So velocity of the particle by here a velocity of the wave when you are talking, which is nothing but here will be getting as maximum particle velocity will be a omega by here velocity of the wave you can write it as omega by k. Omega gets cancelled. Here you will be getting as a into k will be writing. So here a into k in the sense amplitude here will be getting as 10 into, instead of k here it will be 5 will be there. So here 10 into 5 you will be getting as 50 will be getting. So this is the ratio value. Let us see the next question. The next question says the figure shows 4 progressive waves A, B, C and D with their phases is given as A, B, C, D is given, and here with their phases expressed with respect to the wave A. With respect to the A we are going to be representing. It can be concluded from the figure that, so here A wave when you are talking in the sense, okay, A is going to be starting from the origin we will be getting, right? If I am talking about all the initial phases for all the particles, if I am talking here pi initial phase of the A particle will be 0. Why? Because it is starting from the origin. And B particle you will be talking in the sense it will be starting ahead pi by 2. So initial phase for B particle will be getting as pi by 2. And C particle it's going to be starting at the from the negative values, negative 90. So here pi C value you can take as minus pi by 2 will be getting. Now here look at the options here. So the correct option here it will be this is C is going to be lagging. C is lagging behind the phase angle pi by 2. So C obviously here it's going to be lagging by an angle minus pi by 2. And the wave B is ahead of the phase angle pi by 2. This is all here they are asking here expressed with respect to the A they are asking here. With respect to the A, here C is going to be lagging minus pi by 2 and B is ahead of the A will be getting as pi by 2 will be getting. Right. So the correct answer will be second is the correct answer will be getting.